Okay, so today is determinants of 3 by 3 matrices. It's really not that difficult to do, but I'll do my best to make it as clear and as quick as I can do it. So how do you find the determinant of a 3 by 3 matrix? And as a reminder, I just want to talk about the determinant of a 2 by 2 matrix. So let's say let A be a matrix A, B, C, and D. Then the determinant of the 2 by 2 matrix A is equal to A times D minus B times C. Okay, and you've learned that as a formula, and that's great, but it's not exactly clear why this is actually the determinant. I'm going to try to make this a bit more explicit. Okay, determinants for every square matrix always follow this kind of pattern. Now, I told you this as a formula, but I want to show you kind of a way that this works. Okay, so we get determinants by expanding in any row or column. Any row or any column. And it always is the same form. And in fact, I'm going to start with this one here. So let's take this matrix here. A is equal to, I have A, B, C, and D. Okay. And the way this works, okay, is that I decide which I'm going to expand in. I'm going to expand in the first row, which means that I have my A and my B. Okay, so my first component here is A. Okay, and what I do is I delete the row and the column that A is in. Okay, so you can see that I only have the number D there. Okay, so what I'm going to do is I'm going to delete the first row and the first column, and I'm going to multiply A by the number that's left when I delete the row and the column. Okay, in this case, the determinant of the 1 by 1 matrix that is left. Okay, so I have A multiplies D. Okay, then I do the same thing for B. I delete the row and the column that B is in, and I multiply by the determinant of the 1 by 1 matrix that is left. So that's B times C. Okay, that's expanding in the first row. I have A times D and I have B times C. And we always have a plus minus rule, okay, which looks like this, okay. The expansion matrix has the following shape. It is plus, minus, minus, plus. We'll also call this the sign matrix. Okay, sign matrix. So the sign for the A, when I expand an A, is going to have this plus. And when I expand for B, I'm going to have a minus, which means that my determinant for A is equal to A times D, which I've worked out, and then I have minus B times C. Now I got this by expanding in the first row, but I could have expanded in the first column. Then I would have had A, delete the row and the column that A is in. I would have the D left, so A would pair with D again, and it would have a plus sign. Then I would delete C, the row and the column that C is in. Okay, so I would have B left, so C would pair with B again, okay, and it would have a minus sign. And in fact, any combination that I take, expanding in any row or any column here, I'm going to get exactly the same thing, okay? It's always going to have this form, okay? This is how determinants are actually defined. They're defined by this process. The determinant of a 1 by 1 matrix is the number that it is, okay? And then for larger matrices, we have this sign matrix, and we have this deletion process where we delete a row and a column, and we associate the determinant of the smaller matrix that's left with the number that I've covered, okay, or the number that I'm expanding in, okay. So let's do a 3 by 3 one, and then we'll talk about how this would have to work. Okay, so I have an example here. I'm going to follow exactly the same procedure. Okay, I'm going to have a matrix here, which is a bigger matrix. We're going to call this B. Okay, it's 5, 0, 8. I have 2, 6, and 4, and I have 1, 3, and 7. And I want to find the determinant of B. Okay, so this is a bit more complicated, but it's the same basic idea. And now that I know where this formula comes from, I'm just going to apply it to this one as well. Okay, so I can choose to expand in any row or any column, okay? I can choose to expand in any. Okay, and I want to underline that because it is important. Any row or column. Okay, any row or any column. Okay, we can choose to expand in. Okay, now we're going to expand in the first row, just because that's what I did here for this 2 by 2 case, and now we're going to repeat the same procedure. Okay, so if I'm expanding in the first row, my first entry in the first row is this number 5 here. Okay, so I have the number 5. Okay, and now let's cover the row and the column. I did that in reverse order, but column and row, that 5 is in. And we see that I have a 2 by 2 matrix there, okay? And I want the determinant of that 2 by 2 matrix. So the way this works is that now that I've deleted the row and the column, I need to find the determinant of this 2 by 2 matrix. By the way, a straight line on a matrix on either side, not a bracket, but a straight line, that refers to determinant. So here I have 6, 3, 4, and 7. Okay, that's my first value. Okay, a question which is pretty simple would be, what is the determinant here of this 2 by 2 matrix, which is the thing I'm looking for? And of course here we can just use the standard matrix formula that we've learned before for 2 by 2 matrices. So this is going to be equal to what? It's going to be equal to 5 times, and then I have my standard AD minus BC, 6 times 7, minus 3 times 4. Okay, and that's my AD minus BC formula. Okay, and what do I end up with? Well, this is 5 still on the outside. Okay, 6 times 7 is 42, minus 12, so that is 5 times 30, which is 150. Okay, so I've expanded in the first row here, but that's okay. So that's my first entry, the entry in the 1, 1 position, first row, first column. I'm going to stay in the first row. And we see that my second entry is this 2 here. Okay, so now I have a 2 in that position, and I want to find the 2 by 2 matrix that is left when I delete the row in the column that 2 is in. And we see I have 0, 3, 8, 7. Okay, so this is the matrix I have left. I have 0, 3, 8, and 7. Like that. Okay. And again, fairly simple to do now because this is a 2 by 2 matrix. I can use the standard formula that I had before. Okay, so I have 0 times 7, and I need to subtract away 3 times 8. Okay, so this is 2 times minus 24, which is minus 48. Yeah, I want to do it this way for the moment. Okay, so this is minus 48. Okay, I don't want to rush to the next step. Okay, and then my next step, okay, is that I have, let's go with, here I would have my next value, which is a 1. Okay, so we see I have a 1 here. Okay, I have the 2 by 2 matrix that's left when I delete the row and the column that is in. Okay, and I delete the row and the column that the 1 is in, and we see I have 0, 6, 8, 4. Reading the rows, 0, 6, 8, 4. And that, of course, the 1 is not relevant, it's just number 1. Number 1 doesn't change anything. I have 0 times 4, and I have minus, and I have 6 times 8. Like that. And that there is going to give me 1 by 6 times 8, which is minus 48. Okay, so those are my values. Okay, those are the values that I'm interested in. Now, okay, I need to adjust them according to the expansion matrix or the sign matrix. Okay, and the sign matrix has a very similar form in 3 by 3. It's very simple. Okay, it's not difficult at all actually. It's plus, minus, plus, minus, plus, minus, plus, minus, plus. Like that. Okay? Plus, minus, plus in the first row, minus, plus, minus, plus, minus, plus. Okay? And now what I need to do is I need to take these values that I've just worked out. Okay? So the determinant of B then is equal to what? Well, it's the values I've just worked out, which were 150. I had minus 48. And I had minus 48. Like that. And now what I need to do is I need to take these 3 separate values and apply the signs that I see here. We see this was expansion in the first row, so the first one gets a plus. The second one gets a minus, and the third one gets a plus. Okay, so that's my answer. Okay, and the total is 150. Okay, because the minus by minus gives plus, that cancels with this one here. So I have 150. It's a pretty big number, but you know, 150 is not so big that we can't work with it. But the really important thing is that the determinant of B is not equal to 0, so B inverse exists. Okay, and I know some of you now are not going to believe me that you can expand in any row or column, but we in fact can do that, and I would like to do a repetition of this exact calculation, but just on a different row or column. Okay, so I did a row, so I'm going to do a column. I did the first row, which had starting with a plus. I want to start with a minus, so I'm going to expand in the second column. Okay, that's not necessary. I could choose to expand in any of them, like I said, but this is what I'm going to do. Okay, so another expansion. Okay, we'll do another expansion. This one's a little bit different. Okay, so we see I have a 2. That's the first one, first entry in the second column. So I'm going to take that 2. Okay, and I'm going to multiply by the 2 by 2 matrix that is left when I delete that 2, the row in the column that 2 is in. So we see I have 0, 3, 8, 7 again. Okay. Fairly straightforward. This is going to be 2 times, I have 0 times 7, and I have minus 3 times 8. Okay, and what do I have there? That's 2 times minus 24, so that's minus 48 again. No issues. Okay, fairly straightforward. My next entry is a 6. Okay, it's this one right here. It's the second entry in the second column. So now I have 6. Okay. Okay, and now I want to delete the row and the column. It's always a little bit awkward when it's the middle one. Okay, but I think you can see there that it's 5, 1, 8, 7. You'll see that? 5, 1, 8, 7. Okay, so 5, 1, 8, and 7. Okay, so this is 6 times, and what do I have? I have 5 times 7. Okay, and I have minus 1 times 8. Okay, so this is 6 times, and I have 35 minus 8. Okay, so this is 6 times 35 minus 8 is 27. So 6 times 27. Okay, 6 times 20 is 180. 6 times 7. I'm going to grab a calculator. 6 times 7 is 42. So this should be 222, I think. 6 times 27 is, oh no, 162, of course. I multiplied it by 30 rather than by 20. Okay, so it's 162. Okay, 162, no problem. Okay, now I have the final entry in the column, which is a 4. Okay, I have the 2 by 2 matrix that is left when I delete the row and the column. Okay, so I'm going to delete the column and the row, and we see I have 5, 1, 0, 3. So 5, 1, 0, and 3. So this is going to give me 4 times A times D is 5 times 3. And I have minus 1 times 0. Okay, like that. So this is 4 times 15, which is 60. Okay, 60. And now what I need to do, I think I must have made a mistake on sign somewhere. No, actually it's fine. Okay, it's fine, sorry. Okay, so this is my work, okay, that I've just done. And now I have my sign matrix. Well, my sign matrix is plus, minus, plus, minus, plus, minus, plus, minus, plus, like that. Okay, and now, according to my expansion, I went in the second row, second column, so it goes minus, plus, minus. My numbers now for the determinant of B I had these numbers. I had minus 48. I had 162. Okay. And I had 60. Okay. And now I need to take these numbers and correct them according to this sign matrix. So minus plus minus, that gets me minus a plus a minus. Okay. This one brings me up to 210, take away 60, and I get 150 again, which is exactly the same number. Okay. And actually this will work given any row and any row or any column anytime I like. So a question would be, should I choose any particular row or column? And the answer is that it's sometimes beneficial, okay? And I'll explain why, okay? How do you choose your expansion? Okay, well, let's have a look here. Let's have a quick example. I'm not going to write it all down, but do the whole expansion again, but consider this matrix. I'm going to call it C. We're going to say that C is the matrix. I need some numbers. Let's go with 2, minus 1, 5. 0, 7, 0, and then 3, 0, 6. Okay. Now what we notice about this matrix is that it has a couple of zeros in it. And zeros are helpful because anytime I expand zeros, it doesn't matter. For example, say I'm expanding in this third row. It doesn't matter what happens when I get rid of the row and the column, because I'll be multiplying it by a 0, so whatever I get is going to stay as 0, okay? So generally, I recommend finding the row or column with the most zeros. For expansion. Why do I recommend choosing this one? Okay, well, it's very simple. It means that I have less actual sums to do because I know that the answers are going to be 0 in advance. So let's say here I look at this C here. If I choose to expand in the first row, I'm going to have a 2, a minus 1, and a 5 sitting on the outside, and I'm going to have to calculate some determinants. It's not so good. If I if I expand, say, in the third column, I have 5, 0, and 6. 5 is a number where it will multiply by a 2 by 2 determinant, and it's something I'm going to have to calculate. But the 0 and the 6, the 0 is going to multiply by a 2 by 2 determinant, whatever that might be, give me a 0, and the 6 is, again, is more work that I have to do. So if we look here, we can see, okay, first row has no zeros, the second row has 2 zeros, the third row has 1 0. Now for the columns, every column has exactly 1 0. So the best choice here is to expand in the second row because it has 2 zeros. Okay. Okay, the second row has 2 zeros. So if I wanted to find the determinant of C, how would I go and get it? Well, let's have a look. Okay. I would choose to expand in the second row. Okay, and the second row is 0, 7, 0. So the first value is 0. Okay. And then there's the 2 by 2 matrix determinant that's left, okay, when I delete the second row and the first column. Okay, so I delete the second row, first column, okay, and we see that I have minus 1, 5, 0, 6. So minus 1, 5, 0, and 6. Now, this has some determinant calculation that I might have to do, but the 0 is going to multiply whatever I get, so I know that's just going to give me a 0. Okay, second one is a little bit trickier. We see I have a 7. Okay, I'm only going to do this one way. Okay, so the 7 here in the middle, it's in the second row and the second column, so I have 2, 5, 3, 6. By deleting the second row and second column. Okay, we'll work that out. That's 7 times, and now I have 2 times 6 minus 5 times 3. Like that. That's 7 times 12 minus 15, which is 7 times minus 3, which is minus 21. Okay, I just made that number up. I mean, I made the matrix up. I didn't plan that one. Okay, and then my next one is a 0 again. So I have 0. Okay, I have a 2 by 2 matrix that's left when I delete the row and the column. So second row, third column, that gets deleted, and I have 2 minus 1, 3, 0. Okay, but it doesn't matter what the determinant of the 2 by 2 matrix is, that's always going to give me a 0. Okay, so that's fine. So now the determinant of the matrix C is what? Well, my three numbers were 0, minus 21, and 0. And all I need to check is if these need to be modified according to my sign matrix. Okay, and when I look at my signs here, we see that I have minus, plus, and minus. Of course, the zeros don't do anything, so all I'm left with is minus 21, okay, which is of course not 0, which means that C inverse exists as well. Okay, so that is how I would recommend prioritizing a particular row or a particular column. Okay, but what I would strongly suggest is that if you don't see one which is immediately more beneficial than another, so for example, if you decide, okay, I don't see any zeros or I don't see a better way of doing it, just have one that you always fall back on. If I don't see zeros, so say for example, I look at a matrix that has no zeros, I always expand in the first row. Always, every single time, okay? I only expand in columns or in a different row if I know that there are zeros that I can take advantage of. Otherwise, I don't bother, okay? So that's how you find the determinant of a 3 by 3 matrix, okay? The next thing we're going to have to talk about is something called cofactor expansion, okay? And cofactor expansion is, it's kind of a pain, to be honest, but it's relatively simple. And I'll try to explain how it relates to the 2 by 2 case that we saw as well, okay? So I'm going to let this video end here because I'm getting close to the half-hour mark. I hope this is helpful. I hope this gives you a quick guide on how to find the inverse of 3 by 3, sorry, the determinants of 3 by 3 matrices. Okay, thanks everyone. Bye.